Greetings, science family. Today we're looking at kinetic and potential energy practice problems, and we're jumping to questions number 25 through 30 or so. But let's do a couple examples. So for number 25, it says calculate the potential energy. So we're looking for PE, potential energy. Think about potential energy as this equation, right? Stored up energy. If we have a 5 kilogram object that is sitting on a 3 meter ledge. So first of all, we know, what do we have? We have something that's 5 kilograms, right? That's the mass. And we know that it is 3 meters high, so that is the height, right? We know we want to solve for potential energy, so that's our question. And we know that our equation to solve for that is right here. Potential energy is equal to the mass times 9.8 times the height. So can we plug into that equation and solve for it? Sure. Potential energy, which we don't know, that's what we're solving for, is equal to the mass. The mass is right here, 5 kilograms, times 9.8, which is always the acceleration of gravity, times the height. And the height right here is 3 meters. So when I multiply all three of those across, 5 times 9.8 times 3, I end up with 147. Now, since it's energy, what are the units going to be? Remember, energy is always measured in joules, J. So that is your answer for number 25. Fine. Let's move on to question number 26. A rock is at the top of a 20-meter tall hill. So first of all, something that's 20 meters, that sounds like up high, that sounds like the height. It says the rock has a mass of 10 kilograms. All right, so 10 kilograms, to me, sounds like that's the mass of the rock. We want to know how much potential energy does it have. Fine. So it looks like similar to the previous problem, we're looking for potential energy. Now again, if you look, potential energy's formula is potential energy is equal to the mass times the acceleration of gravity, which is 9.8, times the height. So now that we have all the information and we need to solve for potential energy, let's plug into the equation. First of all, mass is what we're going to use first. That's 10 kilograms. Mass needs to be in kilograms. Next is 9.8. That's always the number when we're on planet Earth. We assume the acceleration of gravity is 9.8. And then for height, height is going to be 20 meters off the ground, so we're going to put the 20 right there. When we multiply all three of those numbers together, 10 times 9.8 times 20, we end up getting about 1,960. And since it's energy, potential energy, we measure it in joules. So there we go for number 26. Jumping to number 27. It says you have a 2.55 kilogram object. Anything in kilograms we know means that it's the mass. So they gave us the mass. It's 3 meters up in the air. So if it's 3 meters up in the air, that means it's the height it's giving us. And we want to know how much potential energy it has. So our potential energy is what we're looking for. We know the last three problems. The equation for potential energy is mass times gravity times height. And remember, gravity is always that 9.8. So let's plug into our equation to solve for it. Potential energy is what we're solving for. Mass is first, and our mass is 2.55 kilograms. Our gravity is next, which is always 9.8. That's the acceleration of gravity on Earth, we assume. And the height of the object is about 3 meters up high. So anything up high has stored up potential energy. That's why we can solve for it. And when we multiply 2.55 times 9.8 times 3, we end up getting about 74.97 joules of energy. Perfect. Looking at question 28, it says how high up? So high up, that's height. It sounds like they're asking about what the height of the object is. If you have a 3 kilogram object, so first of all, if we have something that's 3 kilograms, that means we have its mass. And there's 300 joules of potential energy. Ooh, okay. So they gave us the potential energy stored up. That's potential energy. We want to know the height of the object. And we know, of course, that potential energy is equal to mass times the acceleration of gravity times the height. Can we plug into our equation and solve for it? Sure we can. First up is potential energy, which we have is 300 joules. So we're going to put 300 is equal to the mass. The mass is going to be 3 kilograms. 9.8 is next in the equation, so we'll put 9.8. And of course, the height is next. For the height, we don't know it, so that's going to be, of course, our variable. So now that we have that, let's start solving to get h all by itself. So what I can do, of course, is if I pull my calculator out, first of all, 300, I'm going to drop down. I'm not doing anything with 300 yet, but I can do 3 times 9.8. And when I do that, I end up getting about 29.4 when those are multiplied together times h. Now I want to get h all alone, and since 29.4 is multiplied, I'm going to divide 29.4 to both sides. We'll just use our algebra skills. Now that we do that, let's take 300 divided by 29.4 in our calculator. And when we do that, we end up getting about 10.2. Now this is for height, right? So let's think about what the unit is for height. Well, it's just the distance of how high up you are, so that's going to be in meters. So our answer ends up being 10.2 meters is our height. Now that you have that, let's move on to number 29. I have a 4 kilogram rock rolling 10 meters per second. Wow, okay. So first of all, I have a 4 kilogram rock. That's my mass. It says it's moving at 10 meters per second. When I see meters per second, I automatically think velocity. That's how fast it's going. The problem is asking what the kinetic energy is. So that's my big question mark. Now, if you look at the top of your page, remember the kinetic energy equation is 1/2 times mass times velocity squared. Okay, let's plug that into our equation and solve for our problem, which we're looking for kinetic energy. So kinetic energy is what we're solving for, so we leave that as a variable. First, we put in 1/2 into the equation. Next, we put in the mass. The mass is going to be 4 kilograms. And finally, we're going to do the velocity squared. So the velocity is 10, and we'll do 10 squared. All right, perfect. Let's start simplifying this a little bit. First of all, 1/2 times 4 in our calculator is 2, and 10 squared, 10 times 10, is going to be 100. So if we take that, 2 times 100 is going to end up being 200. And since it's energy, we're going to do joules. So that ends up being a kinetic energy of 200 joules total. Hopefully that made sense to you, all right? If not, rewind the video, go through the steps again on how we pulled out that information from the problem. Let's jump to number 30. I've got 8 kilogram cat. So anything in kilograms we know is mass, and it's running 4 meters per second. So if I have 4 meters per second, that means I'm given the velocity, the speed, right? How fast it's going. It's a rate, 4 meters for every second. I want to know how much kinetic energy that object has. So how much energy does this cat have while it's moving? That's what I'm looking for. It's kinetic energy. So I know my kinetic energy equation is 1/2 times mass times the velocity squared. The good news is I have enough information to solve this. So I'm solving for kinetic energy, so I'm going to leave that as my variable. Next in my equation is 1/2, so I'll put that in there. Next is the mass. The mass from the problem is 8 kilograms. And after that is my velocity squared. My velocity is 4, so 4 squared. Now that I have that, let's do some math to simplify this and solve for KE. First of all, 1/2 times 8 gives me 4. And 4 squared is really 4 times 4. That gives me 16. Now that I have that, if I multiply 4 times 16 together in my calculator, I end up getting an answer that is 64 joules of energy. So remember, it's kinetic energy. Energy is always measured in joules. And that ends up being 64 joules of energy. So that cat had some energy as it was running. Do you guys like cats? I had cats growing up, but I don't anymore. They pee all over the house sometimes. Bummer. But I did like them. They were nice cats. Moving on, though. That was number 30. Let's set up 31. Oh, I like this because now we're not finding kinetic energy. It's given to us. You've got a rolling ball. There's 18 joules of kinetic energy. Ooh, this is good. So we've got 18 joules. That's our kinetic energy. It says it's rolling at 3 meters per second. So 3 meters per second means that's its velocity. We want to know what the mass of the object is. So that's what we're looking for. Mass, that's the big question mark. Since we're doing kinetic energy, we're still going to use the same equation we've been using. 1/2 times mass times velocity squared. But now when we plug in, we can plug in different values. So first off is kinetic energy, and I know kinetic energy is 18 joules. So I'm going to use 18 for my kinetic energy. Then I'm going to put 1/2 in there. For my mass, I don't have it. That's what I'm looking for. So I'm going to leave that as a variable as m. Next then, I've got velocity. Velocity is going to be 3, and don't forget it's 3 squared. So you got to put it to the second power. Now that I have that, I can eventually solve for m. Let me do that. So I'm going to keep 18 right there, but I'm going to do 1/2 times m times 3 squared is 3 times 3, so that's 9. Now let's simplify that even more. 9 times 1/2 is going to be 4.5. So if I simplified that, I now have 18 equals 4.5 m. If I want to get m by itself, I've got to do some algebra. I've got to divide both sides by 4.5. When I do that, 4.5 cancels out and leaves m by itself. And then I end up doing 18 divided by 4.5. And when I end up getting that 18 divided by 4.5, I end up getting 4 for my answer. Now here's the problem. Meters, I'm sorry, not meters, but m is mass, right? So it's for what? Think about what the units are for that. Since it's mass, it has to be kilograms. So you see, it's not only good enough to be able to do the math, but when you're solving, you need to understand what the unit is at the end as well. So perfect. That was number 31. All right, family, let's finish strong with number 32. I have a 4 kilogram bird. So if it's 4 kilograms, I know that that is my mass. If it has 8 joules of kinetic energy, 8 joules is energy, that means I'm given KE, kinetic energy. I want to know how fast it's flying. So if I want to know how fast it's flying, I really want to know its velocity. So V is what I'm solving for. As we've been doing with kinetic energy, the equation is 1/2 mass times velocity squared. So that is the equation I'm going to plug into. To start, I start with kinetic energy, which is 8 joules according to the problem. So I'm going to put 8 equals, it's going to be 1/2. I'll carry that in there. Next is mass. My mass given to me was 4. And last is velocity squared. I don't know my velocity, so I'm leaving that as an exponent, or I'm sorry, as a variable. Now that I have that, let's simplify to solve for V. I'm going to bring 8 down, and next I'm going to do 1/2 times 4. 1/2 times 4 is 2, and I have V squared left. Let's try to simplify this a little bit more. Let's get rid of the 2 so V squared becomes alone. I'm going to divide 2 to both sides, as you see. 2 cancels out, and I'm left with V squared is equal to 8 divided by 2, which is 4. Now, a lot of times people think they're done because V's by itself, but it's really not. It's V squared. So we have to get rid of the squared by doing the square root to both sides. That's an important step. Once you square root V squared, it just becomes V by itself. Once you take the square root of 4, use your calculator to do that, the answer is 2, right? Because the square root really is what number times itself gives you that number. So 2 times 2 gives you 4. So 2 squared is 4. So the square root of 4 is 2. But now that I have 2 equals v, the question is, what units should I use? Well, we want to know how fast it's moving, so that's velocity. So the units will be meters per second. So your answer ends up being 2 meters per second for velocity. This is one of the types of problems that gives people the most trouble because they forget to do the square root step. Make sure you don't make that mistake, and you should be just fine. Okay, science family, we went through some potential energy and kinetic energy problems. Hopefully, plugging into the formula and doing the algebra is something you feel comfortable with. If not, feel free to ask questions in class. And of course, make sure you can rewatch this video. It can help you go through the steps so that if you need that extra guidance, it's here for you. Take care and be well.